Word problems. Let us look at an overview of the word problems. The following points outline a general approach to word problems. Read the entire question carefully and get a feel for what is happening. Identify what kind of word problem you are up against. Make a note of exactly what is being asked. Simplify the problem. This is what is usually meant by translating the English to math. Draw a figure or table. Sometimes a simple illustration makes the problem much easier to approach. It is not always necessary to start from the first line. Invariably, you will find it easier to define what you have been asked for and then work backwards to get the information that is needed to obtain the answer. Use variables a, b, x, y, etc. or numbers 100 in case of percentages, any common multiple in case of fractions, etc. depending on the situation. Use smart values. Think for a moment and choose the best possible value that would help you reach the solution in the quickest possible time. Do not choose values that would serve only to confuse you. Also remember to make note of what the value you selected stands for. Once you have the equations written down, it's time to do the math. This is usually quite simple. Be very careful so as not to make any silly mistakes in calculations. Lastly, after solving, cross-check to see that the answer you have obtained corresponds to what was asked. The makers of these GMAT questions love to trick students who don't pay careful attention to what is being asked. For example, if the question asks you to find what fraction of the remaining, you can be pretty sure one of the answer choices will have a value corresponding to what fraction of the total. Translating word problems. These are a few common English to math translations that will help you break down word problems. My recommendation is to refer to them only in the initial phases of study. With practice, decoding a word problem should come naturally. If on test day, you still have to try and remember what the math translations to some English term is, you haven't practiced enough. Addition, increased by, more than, combined, together, total of, sum, added to, and plus. Subtraction, decreased by, minus, less, difference between or of, less than, fewer than, minus, subtracted from. Multiplication of, times, multiplied by, product of, increased or decreased by a factor of. This type can involve both addition or subtraction and multiplication. Division, per, out of, ratio of, quotient of, percent, which is divide by 100, divided by each, equals, is, are, was, were, will be, gives, yields, sold for, has, costs, adds up to, the same as much as. Variable or value, a number, how much, how many, what. Some tricky forms. Per means divided by. For Jack drove at a speed of 40 miles per hour or 40 miles per hour. So you write the symbol per. A sometimes means divided by. Jack bought 24 eggs for $3 a dozen. Less than. In English, the less than construction is reverse of what it is in math. For example, 3 less than x means x minus 3, not 3 minus x. 3, since 3 is less than x, like 3 less than x, so 3 times, so 3 quantity less than x. Similarly, if the question says Jack's age is 3 less than that of Jill, it means that Jack's age is Jill's age minus 3. The how much is left construction. Sometimes the question will give you a total amount that is made up of a number of smaller amounts of unspecified sizes. In this case, just assign a variable to the unknown amounts and the remaining amount will be what is left after deducting this named amount from the total. Consider the following. A 100-pound order of animal feed was filled by mixing products from bins A, B, and C, and that twice as much was added from bin C as from bin A. So let A stand for the amount from bin A, then the amount from bin C was 2A, and the amount from bin B was the remaining portion of the 100 pounds. So that would be 100 minus A minus 2A. In the following cases, order is important. Quotient by ratio of construction. So if a problem says the ratio of x and y, it means x divided by y, not y divided by x. The difference between of construction, if the problem says the difference of x and y, it means x minus y. Now that we have seen how it is possible in theory to break down word problems, we can see some examples to see how we can apply this knowledge. The length of a rectangular garden is 2 meters more than its width. Express its length in terms of its width. More than implies addition. Is implies equal to. Thus, the phrase length is 2 more than width becomes length is equal to 2 plus width. Example 2. The length of a rectangular garden is 2 meters less than its width. Express its length in terms of its width. Less than implies subtraction but in reverse order. Is implies equal to. So the phrase length is 2 less than width becomes length is equal to width minus 2. Next problem. The length of a rectangular garden is 2 times its width. Express its length in terms of its width. Here the keywords are times implies multiplication, is implies equal to. Thus the phrase length is 2 times width becomes length is equal to 2 into width. Coming to example 4. The ratio of the length of a rectangular garden to its width is 2. Express its length in terms of its width. The keywords are ratio of, implies division, is implies equal to. Thus the phrase ratio of length to width is 2 becomes length or over width, length divided by width is equal to 2, which means length is equal to 2 into width.